And I think there's a lot of fear now among people who want community intervention, public health intervention, who say, I don't want our solution to obesity be let everybody get obese or let 2/3 of the population get obese, and then we'll give them surgery or drugs for the rest of their life. It's too expensive. It's not my ethos, et cetera, et cetera. And I think they're worried that people like me who say, look at the efficacy data, we need to think about this more, are implying that we should shut down all the other stuff. And at least for me personally, that answer is absolutely not true. But I think we need sub-paradigm shifts within paradigms. And what I mean by that is I don't think the paradigm shift of saying, don't ever think about nutrition anymore, only think about drugs and surgery is warranted. I don't think the paradigm shift of saying, don't ever think about behavior, community intervention, family intervention is warranted. Don't ever think about public health or policy. That's not warranted. I don't agree with those at all. What I do think we need to do is to say within the paradigms of behavior, community, family, policy, let's be honest. Let's look at Carolyn Somerville's data and others and say, there is no compelling evidence that any of this has had a meaningful impact. You can cherry pick here and there. You can say this policy led to differences in how much of that food was purchased in this context. Even if that's true, and sometimes those are a little shaky, those conclusions, say, did it lower obesity rates? And those have never been shown.
Hey everyone, welcome to the Drive Podcast. I'm your host, Peter Attia. David, good to see you once again.
Good to see you, my friend.
Lots to talk about today. The world of nutrition and health are always in the spotlight. In particular, around a class of drugs that no listener to this podcast will be a stranger to, called GLP-1 agonists. So I want to spend some time talking about those, but I think before doing so, I want to just maybe go back and talk a little bit about what we know and maybe don't know about the relationship between nutrition and obesity.
Sure.
Which sounds like it should be obvious. So tell us what you think is actually known about the relationship between food and body composition.
So I like the way you phrased the question and using the phrase body composition as opposed to just obesity or weight. There are obviously three different things. Obesity implies a threshold, you're too much. There's a judgment about the quantity or the effects of the excess. Then there's body composition, the tissue, how much is fat, how much is lean, where is the fat lean, what is the fat composed of, what is the lean composed of. And then there's just weight, which is just, your mass on this planet. And those three things are highly related, but not identical. What we know indisputably, and even people who sort of rail against something they call the energy balance model, which you and I have discussed, whether it's really a model is unclear. It's really more of a constraint. It's really a restatement of the first law of thermodynamics, which is the law of conservation. That matter and energy can neither be created nor destroyed, but only converted. It is a constraint by which all other descriptions of what happens with weight and mass and food intake and energy expenditure must operate. It's not a description or an explanation of what happens. It just says if you describe any proposed explanation of what happens, it's got to follow that first law of thermodynamics in order to make sense. And that first law of thermodynamics in the field of nutrition obesity often gets stated as something like changes in energy storage equal changes in energy intake minus changes in energy output, or delta energy stores equals delta energy in minus delta energy out. Food intake can affect those things. Alternatively, you could say that energy intake is one of those things. So it gets back to that descriptive thing. Now, one of the questions becomes, how does all the other aspects of food, besides the mere energy content of it, affect the amount of weight one gains or loses, the body composition, the tissues, where the mass is distributed, what types of tissues it's in, composition of those tissues, and then, of course, whether or not one exceeds some threshold. There's every reason to believe that many, many aspects of food, from the marketing and pricing of it, which then can influence the intake of it and other things as well, to the taste, the smell, the timing, what you eat it with, what it's combined with, phytochemicals in it, micronutrients, macronutrients, all can affect energy expenditure, subsequent energy intake, or nutrient partitioning, which is a fancy phrase for where you stick the energy that you store in the body. Do you stick it into fat or muscle or bone or visceral fat or subcutaneous fat, et cetera? So all those things can come into play. Now, what do we really know? The truth is, I think what we know is modest, and partly that's because it seems to me to be very specific. That is, we can do a study, and even when it's honestly done and well done and honestly reported, and we find that in this species, with this delivery of this composition in this way, this thing happens. And then when you look in a different species or a slightly different food, you get different results. So there's many, many studies saying, well, we got this with pea protein and casein, but not whey. Or we got it with whey, but not casein. Or we got it when we fed it 2 hours before the test meal, but not 1 hour before. Or we got it in men, but not in women. This makes me think we're talking often about subtle effects that may not be that clinically reliable and meaningful. And so the really big effect seems to be how many calories do you eat? But all these other aspects of food may then influence how many calories you eat, either of that food or in subsequent occasions. And those can seem to have big effects, but we're still sort of, I think, trying to suss those out.
Do you ever spend time interacting with physicists or chemists, biochemists, who sit on the sidelines and sort of look at the field of human energetics and sort of wonder to themselves, why is there so much noise and why is there so little understanding? And I don't think anybody is standing around blaming the scientists and saying, well, you know, in physics, we have great scientists. In chemistry, we have great scientists. In human energetics, they must be subpar, and that's why they don't know anything. I can't imagine there's anybody that thinks that. What do you think it is at the meta level that explains the obvious but important observation that our knowledge in this space is woefully deficient relative to the effort that has been put into elucidating truth? Why? Just to restate that more poignantly, for how hard the field of science has worked to try to get at the questions we're going to discuss today, why do we know very little relative to the same amounts of effort that have gone into physical sciences, for example?
I think there are many reasons. Some are perceptual and some are actual. Some of the perceptuals, do we really know that much less? And we can argue about it. I think there's still questions in physics where you say, gee, we really don't know that exactly how is it that relativity and quantum physics are compatible, or is dark matter real, or what have you. I think there are questions there.
Though I would sort of just interject for a second, David, and say another way to think of it would be, if you look at the amazing progress that has been made, that has been enabled by the knowledge of physics and chemistry, right? If you just consider what's happened in the last 100 years in terms of what we've been able to do, you know, just look at computing power, look at, you know, semiconductors, look at airplanes. I mean, look at technology that has been enabled by engineering, physics, chemistry. We're multiple logs of advancement. The same cannot be said of what we're talking about now, right? Our understanding of obesity 100 years ago versus our understanding of obesity today, while maybe greater, hasn't actually translated into a multiple log improvement in the outcome of interest, which in this case might be a reduction of obesity, just as it might be in, the interest on the other side, which would be computing power.
Right. Yeah. And again, I think that's only half true. I think we don't give ourselves certain credit for certain things. In physics, there's not a lot of discussion in modern times of the power of Newton's universal law of gravitation. That was a pretty big deal and a pretty big accomplishment, but we don't talk about it a lot because it's been figured out a long time ago, and we take it for granted that we know that now.
But do we even have the equivalent in energetics?
Yeah, I think we do. Some simple examples, both at the practical level. In this country and in most industrialized countries, there's very little food shortage. That's a big deal. It is a big deal that we know that alcohol contains calories. We take that for granted, but Wilbur Atwater, who's the person who stated that, was vilified for it at that time by the temperance movement. And because they wanted to say, and he himself was a teetotaler, by the way, that alcohol had no calories, that alcohol had no nutritional value. And he said, no, it does. It has 7 kilocalories per gram. And so that's an example. Folate supplementation, which has radically reduced spina bifida, iodized salt, micronutrient deficiencies being maybe not eradicated in this country, but radically reduced due, among other things, to supplementation, greater food safety. So we've made a lot of practical progress. We've feeding a number of people through nutrition and agriculture that back all the way to Malthus, but even more, recently in the 1970s when we were told there was going to be a population explosion that would threaten our ability as a species to survive.
But isn't that really more about agriculture than nutrition science?
It's agriculture, it's food science, but some of the nutrition science is more the micronutrients, all the way back to eliminating scurvy through the work of James Lind and figuring out eventually that it was vitamin C. They first thought it was just citrus in general. They didn't understand it was the vitamin C. To the folate and so forth. I think our notions, our understanding about LDL cholesterol, which again, you know more than I about, which is very important, and the role of saturated fats in that. We're still learning more, but we do know some things about that. So I don't think we want to take for granted that we have learned a great deal. In obesity itself, until about, maybe 5 years ago or a little more, when I would give talks about this, I would say, we actually have learned a lot, but it's just not all that clinically relevant. And what's clinically relevant is mostly truly in the clinic, not in the community and the population. So I said, we've learned a lot about genetics, and that's true. We have log orders, I would argue, magnitude increase in our knowledge about the genetic underpinnings of obesity that we didn't have prior to 1980. But until recently, we've had moderate improvements in the clinic and virtually no improvements in the sort of public health community sort of domain.
If you allow me to be humored with an analogy, though, just because I'm going to keep pushing back on this a little bit. When the Wright brothers first put an airplane into the sky, I don't think anybody would have said aviation is amazing. Right? Like that was a proof of concept. It was a wonderful example. But I think it's safe to say that almost monotonically, aviation has become safer and safer and safer over the past 100 years. And I think that allows us to say our understanding of Newtonian physics, Bernoulli's principle, material science, all of the things that enable aviation to be what it is today relative to 100 years ago are probably getting better. And we're also getting better at applying them to a real world problem. Conversely, if the rate of airplanes falling out of the sky were increasing steadily over the past 50 years, such that, in 1970, whatever, 10% of airplanes fell out of the sky, but today 50% of airplanes fell out of the sky, I don't think anybody would be walking around saying, we're doing really well. We understand much more about the physics of the airplane. Yes, it's true. More of them are falling out of the sky. And yet I would argue that in the presence of all of this knowledge that we have, we're getting fatter and we're getting sicker.
Right.
So how do we reconcile the fact that our knowledge is somehow increasing and we're so much more knowledgeable, and yet the actual problem that matters seems to be getting worse, not better?
Right. Well, what we don't have is, again, with a couple of exceptions we're going to get to later, I think, we don't have the sort of sea change, the real orbit jumps in knowledge of a utilitarian, useful knowledge that helps us change the way we do things now that lead to better outcomes. That we don't yet have.
So again, we have useless knowledge?
We have knowledge.
What's the contrapositive of that?
We have knowledge that is useful for understanding and we hope we can build on to get to practical knowledge. Steve O'Reilly gave a nice talk about this about 2 years ago at the Royal Society meeting that he and I and others spoke at and hosted. And he said, as a physician, geneticist, biochemist who works in the field, he looks at this and he also thinks about his early days in blood pressure. And when he started his career a few decades ago, he said, we didn't really have a lot of good drugs in blood pressure. And people kept hammering at the molecular biology and the biochemistry and the physiology of blood pressure. And bit by bit, things started to break. And he says, now we can treat blood pressure enormously better. And he said, I think that's where we're going to go with obesity. And he said, but we're just sort of getting to the breaking point. And I think that's what we're seeing now with the GLP-1 agonists, as well as some other drugs.
So in other words, we might get to a point in 30 years where we're sitting here and obesity rates are back to the level they were 50 to 100 years ago. Virtually everybody will be on a drug, which we may or may not understand the mechanism of action for.
I think we will understand more of the mechanism of action 30 and 50 years from now, but it is true that today we don't fully understand the mechanisms of action. There'll
that's
be
an interesting analogy,
drugs.
though. I think that's a reasonable analogy, comparing it to blood pressure, or comparing it to lipid management, for that matter. Even
That's
40
right.
years ago, we didn't really have tools to manage lipids.
And where is the investment going? Right. So there, the investment was going not only, but heavily toward biochemistry, molecular genetics, physiology, and pharmaceuticals. We are now seeing an uptick in that. We've seen an uptick, and we're seeing more of an uptick in that because some success is being achieved. And the pharma companies, many of which who over the last few decades would be, tepidly in and out. They'd dip their toe in the water of obesity, wouldn't go so well, they'd pull out. Now they're saying there's real success coming.
So there were a couple of recent Cochrane collaborations that came out discussing the success or lack thereof of public health initiatives around obesity. Do you want to say a little bit about those, and maybe also talk a little bit about the history of why, if I'm going to be blunt, if I'm going to extrapolate from what we've just said, one would say that public health efforts to curb obesity have been a failure. And the future of obesity management will be pharmacologic, not public health related. Is that a fair prediction?
I think it's a very reasonable prediction. I'm not sure it's one I will share completely. I would share the first part, that public health efforts to affect obesity in a meaningful way have thus far been singularly unimpressive. And we'll come back maybe a little bit to why and where that's going and where we should go with it. I do think that in the present, and even more so in the not too distant future, clinical management, including surgery and pharmaceuticals evermore, will be ever more powerful, safe, effective, and utilized. I don't think they will ever become the complete solution, and I don't think that there's no solution in public health, but I think we've got to approach it differently. So let's go back in time a little bit. When I started my career sort of as a real professional, basically, 1991, I come to New York, the New York Obesity Research Center at Columbia University and St. Luke's Roosevelt Hospital. It's the only federally or NIH-funded obesity research center at the time. It's the first. It's run by Xavier Pissigny, the legacy of Ted Van Italy. Across the park, you've got Jules Hirsch, Rudy Leibel, and that group at Rockefeller. And it wasn't at the level of of public interest that it is now, the topic of obesity. What you had is these very interdisciplinary groups: physiologists, geneticists, physicians, psychologists, statisticians, nutrition scientists, et cetera, all working together on these problems. Many had been working together for decades, very academic, but also clinical. And you had the powerhouses that were in that region. You had Mickey Stunkert over at UPenn, you had Marcy Greenwood and others at Vassar, and so forth. And if a young person like me made some foolish statement in a seminar about some aspect of physiology or medicine that showed that, given my training, I had no understanding of what the heck I was talking about, one more senior person would put me in my place, but in a very constructive way, and explain that I didn't know what I was talking about. And the statisticians would argue with the physiologists and so on. So you had a depth of knowledge and a real depth of expertise and an understanding. Then NHANES 3 data came out, and there was the sense of crisis and panic, public health.
That was what, 94?
It started to come out in the early 90s, the midpoint of it, like 90, 91, was just starting.
Tell folks what NHANES is and what the data showed.
This is the National Health and Nutrition Examination Survey. It was, at the time, only done every few years. So first there was something earlier in the 60s called NEFIS, I think, National Health and something else. Then they developed the National Health and Nutrition Examination Survey. They did 2 of them. And then the third one was done, I think, between 88 and 93, maybe. So I think the midpoint data they released around 91, if my memory is right. And people started using the word epidemic, and they saw what looked like a jump. Whether there's a real jump or not around the late 80s or in the 80s is actually not so clear. If you look at skin folds, you see less of a jump and you see the increase starting earlier. If you look just at BMI and you look at increase, it's been going up for hundreds of years. The data from the Nobel laureate Robert Fogel, who won it in economics, he's since deceased, but he's a terrific, generous guy. And he collected all these old data on, British naval cadets from the 18th century and French cadets and Civil War soldiers and recaptured slaves during the Civil War, and looked at these different groups. And you see that obesity levels in BMI have been increasing for centuries. But they clearly did seem to be an acceleration, and that caused a panic. And then you had probably the most powerful voice at the time in this domain, was Kelly Brownell. Kelly had been a real devotee of Mickey Stunkert. He was one of Mickey Stunkert's proteges, mentorees. And he was a behavioral psychologist, still is a behavioral psychologist, doing behavioral treatment. As a grad student, I'd go to his lectures and learn the mechanics of how to do behavioral treatment, cognitive behavioral therapy for obesity.
Meaning CBT to help people eat less, eat less, exercise more,
and so on. And then he had a change I guess this would have been the very late 80s, early 90s. He, shortly thereafter, switched to Yale. He got a MacArthur Prize, the so-called Genius Award, and he started to look at maybe concerns about the negative effects of obesity. And he was one of the most powerful, not the first, but one of the most powerful voices to start raising questions about the effects of yo-yo dieting or weight cycling, going up and down. Are we doing more harm than good? Are we just building false hopes up for people because obesity treatment is useless? And that started to change. And then he morphed into, it's the environment. And he introduced, at least as far as to me, the phrase toxic environment. we live in a toxic environment. You can't drive down the street, he would say, without encountering a fast food restaurant. And so this is the problem. We need to stop the individual treatment. He sort of abandoned his roots. And so we need to go to the public health treatment. Many others were grasping that idea, inspired often by him, but others on their own. And the public health community rushed in. And the public health community...
And this was a community that was, up until that point, working on smoking or what types of...
Smoking, food safety...
Leaded gasoline.
All kinds of things like the sanitation, vaccination, so on. They rushed in, and I think there was a lot of sense of, this is simple. People eat too much, they don't exercise enough. Eating less is good. Eating more quote-unquote healthy food is good. There's something about the... some foods are considered healthy, some are not. And if you eat the healthy food, something magical will happen. More exercise, of course, without any real understanding of this. I've had public health people who said to me, one person wrote and said, well, I think if we got people to not walk with their iPhones, then they would walk a little faster and then they would expend more energy while they're walking across campus, and that will help with weight loss. And what do you think? And I thought, well, we're still going to cover the same distance. There's a nonlinear relationship between walking speed and energy expenditure, and the amount of energy is trivial, and et cetera, et cetera, et cetera. And I just thought, nobody who understands movement science and energetics and kinetics would make such a statement. But if you're a public health person, and you just think, I just need clever ways of getting people to behave the way I already know they should behave, then you come up with ideas like that. That's where, if you're embedded in a group of people, that doesn't happen, right? That wouldn't have happened at the New York Obesity Research Center. If I had said that in 1991, I would have been immediately educated by senior people who had been thinking about this.
So in other words, the public health field wasn't really able to self-police ideas that were not grounded in science.
That's right. One of the things that we're very proud of in our school, School of Public Health in Indiana University, Bloomington, is that we have a kinesiology department, as in exercise science. And we're only one of 4 schools in the United States, schools of public health, that have a named kinesiology department. Now, every school of public health studies physical activity. But studying physical activity and being an expert in exercise science are 2 completely different things. We have actual experts in exercise science who understand this, who treat it as a science and take it seriously. We're very proud of that, and they do great work. So we got a lot of nonsense rushing in the field. We got a lot of things that never would have, in the beginning, you wouldn't have predicted to work. But people tried them because they sounded good, they felt good, gave people a positive feeling. Vending machines, farmers markets, walking trails, without really saying, all right, let's really work this out. How many people are going to do it? If they do it, how much effect will it have? Will they compensate by eating more or less or moving more or less later? Those things weren't done. So we've got a whole couple of decades of lousy, uninformative research.
But while the public health movement was taking hold, what happened to the guard, the old guard, so to speak, that you referred to having learned the sort of the physiology of obesity in the late 80s, early 90s? What was their response to this? Were they a part of the movement? Were they distinct from the movement?
I think it's a mix, as with any thing with many people in politics and money and careers and dominance and egos. All kinds of interesting things happened. So some of the real strong behavioral people rushed in, did good science in the sense of things that were rigorous, but maybe not always well conceived that they were likely to be impactful. But there was grant money to be had, and people went after it and still do, and so be it. Was
this also just driven by funding? Was there a change in funding priority?
There's a lot more funding for obesity, still not as much as many people, including me, would like, not as much as perhaps there could have or should have been, but definitely big increases. There was the Robert Wood Johnson Foundation, which didn't put a huge amount of money in, but put money in, whether it was intentionally or not, in a very strategic way, meaning they put in relative to what NIH or pharma put in, they put in a small amount of money, but it sounded like a big amount of money. It had millions. They made a lot of noise about it, very successfully. They got a lot of careers started. They drew a lot of people into the field around public health, around community intervention, around diversity issues, and that's all to the good. It's great. What I think often happened is the amount of money they were dangling in, again, relative to NIH was small. And so many people would rush in, get started that way, but then they'd go to NIH and get bigger studies. So it did catalyze a lot of activity, and that's good. What we've learned, you can make different arguments about it. The very famous story with Edison, where his backers come to him, and whether it's a true story or not, I don't know, but say all this time and money, and you still have nothing to show for your efforts toward making a light bulb. And he said, "No, I now know 1,000 ways not to make a light bulb." These two new papers you referred to earlier were from Somerville. She was the senior author, not the first author. They're just out in the last week. I just put up a LinkedIn post on them about 3 days or so ago. What they do is, one is in children, 5 to 12, I think. The other is in adolescents. And they do systematic reviews, very thorough, very objective, meta-analyses according to the Cochrane method. And what they find is that for both groups, there is no compelling evidence of what you would call a consistent, reliable, long-term, clinically or public health meaningful effect on preventing obesity in either children or adolescents. I included a lot of adjectives in there, and those are important. Most important one is probably preventing. It didn't say treating, it said preventing. That doesn't mean that treatment of obesity in children doesn't have any efficacy. The second thing is these are community kind of diet exercise interventions.
By the way, how easily do we distinguish between prevention and treatment? Obviously, conceptually, it's trivial. Prevention is reducing the number of new cases. Treatment would be reversal of. But can you give a sense of what reversal of obesity rates look like?
With public health stuff, I think I don't want to say it's zero, because you just always have some spontaneous reversal.
But you said a moment ago that this article focused on the prevention side,
Correct.
Not the treatment side.
Correct.
Was the implication of that that public health treatment has been successful, but prevention has not?
I'm sorry.
I see. Okay.
Clinical treatment, I think there's some evidence for success, more so in adults, but some evidence for success.
Does clinical treatment include drugs and surgery?
Can include, but it doesn't have to.
Okay.
So, the idea of somebody coming to the clinic, they go to see, let's say, a Len Epstein at Buffalo. They go to his clinic and he puts them in a study or what have you for weight loss. I would call that a clinical intervention, as opposed to Len Epstein saying, "I've got an idea. I'm going to go out to the public schools and set these programs up, and we'll try to get everybody to be less obese and see if we prevent obesity." That's how I would distinguish those things. And Len, by the way, he's one of the sharpest cats around, and he's a very good skeptic and a very good commenter on what we really know and don't know in that domain. But what Somerville shows basically is not only is there no compelling evidence for effects, but there's reasonably compelling evidence that given the methods we've used today, the effects are either zero or trivial. And so I think that's really important, because I hear tremendous defensiveness now among people who are not practitioners of pharmaceuticals or favorable toward pharmaceuticals so much, because of the great success of some of the drugs, especially the GLP-1 agonist related drugs. In the same way as in the mid-90s, I heard tremendous defensiveness from the behavioral psychology community and others about genetics, because they weren't going to do genetics. And the Rudy Leibels of the world and the Claude Bouchards of the world were talking it up, and it was going to be big. And they were starting to feel threatened, and often didn't know much genetics, but would try to somehow minimize the role. And I think there's a lot of fear now among people who want community intervention, public health intervention, who say, I don't want our solution to obesity be let everybody get obese, or let 2/3 of the population get obese, and then we'll give them surgery or drugs for the rest of their life. It's too expensive. It's not my ethos, et cetera, et cetera. And I think they're worried that people like me who say, look at the efficacy data, we need to think about this more, are implying that we should shut down all the other stuff. And at least for me personally, that answer is absolutely not true. But I think we need sub-paradigm shifts within paradigms. And what I mean by that is I don't think the paradigm shift of saying, don't ever think about nutrition anymore, only think about drugs and surgery is warranted. I don't think the paradigm shift of saying, don't ever think about behavior, community intervention, family intervention is warranted. Don't ever think about public health or policy. That's not warranted. I don't agree with those at all. What I do think we need to do is to say within the paradigms of behavior, community, family, policy, let's be honest. Let's look at Carolyn Somerville's data and others and say, there is no compelling evidence that any of this has had a meaningful impact. You can cherry pick here and there. You can say this policy led to differences in how much of that food was purchased in this context. Even if that's true, and sometimes those are a little shaky, those conclusions, say, did it lower obesity rates? And those have never been shown, right? None of these taxation, none of the policies.
So how do we do that? I agree with you, by the way, and my own personal, because I think everybody has to have a personal sort of bias if they're being honest. My personal bias is that so many of these public health ideas on the surface just make a ton of sense. Like I can simultaneously hold true the following truths, right? Which is, on the one hand, I can completely see why it was logical in the early to mid 90s to say we have to change the food environment. Mm-hmm. Again, like, Richard Thaler's work, right? Another Nobel laureate, would suggest that that's the answer. You fix the environment, you make the default environment better, and people will opt into good choices. By the way, the default environment used to allow people to eat in a way that was clearly ad libitum, and obesity rates were not what they were. So something about the environment 200 years ago or 100 years ago or even 50 years ago was significantly different from the environment today. It's not that our genes changed, right? Nobody would argue there's been such a genetic drift that the reason that obesity rates are 2/3 as opposed to 10% is due to a change in our species. An environmental trigger or set of triggers seems more likely, and therefore public health solutions towards those seem very logical. So we can hold that truth here. And then we have to be brutally honest with your assessment as well, the same as Caroline's assessment, which is this has been an abject failure. I mean, if at the end of the day, you're only measuring the outcome of interest, it hasn't changed. So, we can say whatever we want, but the outcome of interest hasn't changed. Either people smoke less, or they smoke more, or they smoke the same. And that's the only metric that matters if smoking cessation is what you're after. It's not, do we collect more tax revenue? Are the commercials more or less favorable? Do people, smoke less in restaurants versus not in restaurants? No, we care if people as a society smoke less or smoke more. So given that, how do we still say, and I'm not saying I disagree with this, because again, my bias is there should be solutions in public health. But how do we know after 30 years and billions of dollars with no effect that we should stay within the paradigm of public health solutions and just abandon all of the ones we have when we don't really have a sense of why they failed?
Right. So we definitely don't want to only rely on public health solutions. I would strongly oppose that. I agree with you that there is a superficial sensibility to the public health arguments that were made for the various things tried, and it was reasonable to try them. But I say superficial sensitivity or sensibleness because everything that's true makes sense as once we understand it. If we're wrong about something, then it didn't make sense. We just didn't understand that it didn't make sense at the time. Some of that is assumptions, and it goes back to that public health thing. I had a wonderful lunch with the most generous, interesting person, Daniel Kahneman, who won the Nobel Prize
who recently passed away.
Right, before he died. And he and his wife were gracious enough to allow myself and Michelle Cardell, who now works at WW, was a former student with the group I led, to take them to lunch. And we talk about obesity a little bit, and he's this great behavioral economist. And he says to me, without artifice, he says, well, I think this nudge stuff is really good. And, so you could put things on the menu, and that would make people eat less. And I say, well, that's a good idea. And some things like that are being tried and have been tried. And I said, but the big thing is compensation. Yes, you can get a person to eat a little less in this context, but then if they go home for dinner and they just eat more at dinner, it goes away. And he looks at me without artifice and he says, hold it a second. So you're telling me that there might be mechanisms in people that lead them to adjust for reduced calories.
Yep.
And I said, yeah. And this was a revelation. He said, you've opened my eyes. And I was an economist. He didn't think about this. He's great with math and he's great with creative study designs. But this was, again,
he doesn't understand
rushing
physiology,
in.
of course.
So I think that was a big part. A lot of things didn't make sense because they didn't take into account compensation and many other factors. They didn't take into account magnitude of effect and so forth. The second thing is the data themselves. People published a nice thing about a meta-analysis of nudge type stuff in PNAS, Proceedings of the National Academy of Sciences, a couple of years ago. Someone else just went in and redid it and said, if you adjust for publication bias, it doesn't look like there's much holding up there. So often we're presented with evidence, and we may want to come back to this when we talk about some other things like especially protein intake. We're presented with statements as though we confidently know these. And yet when you really start to open the hood and peel things back, you say, hey, there's not a lot of there on the data. So the data that nudge works is actually shaky. Mm-hmm. So that's the second problem. And the third is we seem to be unwilling to really learn from our mistakes. That is, or I shouldn't say mistakes, unwilling to learn from the outcomes of our studies. That is, unwilling to say, we tried the school-based thing and it didn't get a big effect. We tried it again. Fair enough. Let's try it a second time. Let's try it a third time. At a certain point when you say enough. So if someone were to come to me, and I've been saying this for 20 years now, but I'll say it even more strongly today. If someone were to come to me and say, we've got this opportunity to invest in these big school-based, community-based, public health-oriented trials to reduce obesity levels in children or adults, and we have the money available, we want to do good, should we do it? And I would say, show me how this proposed idea is radically different than what's been done for the last 30 years. And then let's talk. And if it's not radically different, why are we wasting our time and money on that? So I think we really need radically different public health paradigms. We need to stay in the public health paradigm, but within the paradigm, we need a sub-paradigm shift to say nutrition education, modest physical activity, build a little bit of a facility to allow people a little more activity. These have been tried. They don't work. They don't have big, meaningful effects. Let's try something completely different. And it's worth a try. That's what I think we need within the paradigms of public health, policy, and so on. Radically different proposals.
Now, if you were czar of the universe and the ultimate resource allocator, what percentage of resources would you put into a new and different form of public health, i.e. radically different approaches? And what percent would you put into medical treatments for, such as surgery and drugs?
So first, I find it very entertaining to think about being the czar of anything, since my grandparents spent a lot of time successfully escaping the czars. But it's interesting that what I would say is probably a little more in the near term on the clinical treatment, because I think we can make more rapid gains in that, while we need some slower, longer-term assessment of the others. But also I would amp up the non-pharmaceutical, non-clinical, non-surgery a little bit, the funding from the government, because I think a lot of that funding for those other things will come from industry. So, if you look at a budget of a Pfizer or a Lilly or a Novo Nordisk and what they put towards certain areas, and then you look at what NIH can put to those areas, we're not talking about NIH being this overwhelming big dog. And in fact, when you combine the pharmaceuticals on certain areas, they may be much bigger than NIH.
They presumably exceed, yeah. Again, there's still something here that just philosophically doesn't sit well with me, not morally. So I want to be clear. I don't have a moral issue with the remarkable success of the drug class that is now probably going to be the first thing that bends the arc of this. I don't know when the next check-in will be, the next NHANES check-in, but it seems
now it's annual.
Yeah, so it seems likely that very soon, if not already, we're going to see for the first time in 5 decades obesity rates going down. I hope we do. So, but the reason that I'm still a little troubled is that from a public health perspective, we don't have the answer to the question, what were the environmental triggers? I mean, we think we know the answer, but every time we try an intervention against those things, it doesn't work, which makes us call into question what the answer is. So clearly we did not get obese because of a GLP-1 shortage that is now being ameliorated with GLP-1 drugs, right? So clearly we have something that was causing the problem, again, multifaceted likely, and then you have a totally different hack to work around the problem. Which is why you're saying, I think what you're saying, which is we need to do both of these things. We still have to get back to this. But if you had to speculate, what is it about the world in the early part of the 21st century that makes obesity and by extension type 2 diabetes a problem that it wasn't, again, the year I was born? It just was, it's literally a log-fold difference in type 2 diabetes. A log-fold. That's hard to imagine in 50 years.
I think there's multiple closely related factors. I think one is the food supply and its availability itself. I think the second is kind of lagged intergenerational effects. Just for fun, I'm going to try to rebut you on the genetics point, but only pedantically. I think that we have seen genetic changes that
epigenetic changes or genetic changes?
Both, but certainly I'm going to put more direct knowledge, my direct knowledge and confidence on the genetic as opposed to the epigenetic changes. And this is assortative mating, differential mating. Do these fully account for the obesity epidemic? No, of course not. Am I trying to say that they are the biggest influences? No, of course not. But I do think it's important to push back and say these are factors, and they come in through migration, through differential fertility, and through assortative mating. We've written papers about all these, and as have others. If you look in things like Framingham, you see that people in certain BMI ranges have more children than people in other BMI ranges. And some will say, but obese people have fertility problems. We're not asking about how good you are in theory at producing offspring. We're asking how many offspring you produce. And so if richer, thinner people use more birth control and have fewer offspring, and there's some genes for thinness, you're going to reduce their prevalence and vice versa. So through migration, differential fertility, and then the other is assortative mating, which doesn't change allele frequencies, but changes gene frequencies, because you get like mates with like.
But if you had to, again, all of those things make sense.
I just wanted to
They strike me as
that.
Somewhat marginal, though. What fraction
so I
of the
had to be a
increase?
professor for a minute and get the pedantic points out.
Fair. Okay.
All right. So now that's out. I think that it is largely, but not exclusively, the increased availability of a greater variety of foods, of highly palatable foods, of foods that are relatively modest in cost, foods that are easy to acquire, the control of ambient temperature, which makes it easier to overeat foods. You don't want to overeat a lot if there's no air conditioning and you live in Austin, Texas, and it's 110 degrees out, right? But if there's air conditioning, the buffet's okay. And then I think there are some intergenerational lagged effects that we, or at least I, don't fully understand. If you look at the Danish data, Torkel Sorensen and others have written about this. They, for over 100 years, conscripted, if that's the right word, every 18-year-old healthy male into the Danish army. And they have not only heights and weights of each one naked, kind of weirdly, they have photographs of each of them naked. And what you see in these BMI levels is you'll see a period where it's flat for a little bit, approximately. Then you'll see a steep acceleration or steep increase. And then it'll flatten out again a little bit. And then you'll see a steep slope. And this has happened in 3 or more cycles, I think. I don't think anybody exactly understands why. Diana Thomas's mathematical model, she's a professor at West Point, studies obesity. Her mathematical models predict some of that. I don't fully understand how that works, but we might ask her. It does suggest to me, even culturally or behaviorally, there could be some lags whereby the weight of your parents or grandparents is affecting you.
Socially or genetically?
Both, right? So the oocyte that formed you was formed in your grandmother.
Mm-hmm.
So potentially through epigenetic things you've mentioned or others, that could be affecting you. Then there's the cultural part. And I think about it, when I was a kid and we went out to dinner with my dad, and we weren't poor, but we weren't rich. We were decidedly, middle class, lower middle class, creeping up. If we went out and we wanted to, at the local Italian restaurant or something, order shrimp, you had to ask Dad about that. The chicken parm you could order without asking. Shrimp you had to ask, because shrimp was expensive. You can get shrimp by the bucket now at the local buffet for next to nothing. So I'm prepared to eat a lot more shrimp than my dad ever would have thought of ordering or sitting down because of our changing economic times and so on. Now, my kids think nothing about ordering dinner in from DoorDash every night, where I still think, even though I could afford to do it, as well as my kids could, because they're spending my money some of the time, which is great. I'm glad they're doing it. But I think, that just seems excessive to me. It seems too indulgent. So I think there may be sort of levels at which one ratchets culturally as well as physiologically or anatomically. So I think all of these things can be in play. I also think we need to change some of the attitudes. And this is speculative on my part. I have no proof that this is true. But I think one of the bad things that the nutrition field has done, including very much the public health community, which talks about I used earlier, I said the healthy foods that have magical effects, but I also think the low carb advocates and zealots who came up through the late 90s and still exist at present and have very powerful voices, and yet others still. I think there's this sense that there's a right way to eat. Nobody agrees on what the right way is, but there is an underlying supposition that there is a right way to eat. And if you just ate that right way, then you would maintain the weight you want to maintain and the fat level you want to maintain without ever feeling lack of satiety or dissatisfaction or what have you. You and I were talking about our personal diets.
Yeah, but what's interesting about that is that's actually philosophically not that different from a drug approach. In other words, if you constructed a lot of parallel universes, it's certainly possible that if you put everybody on a perfectly adherent version of diet X, Y, and Z on each of those parallel planets, you would eradicate obesity. And by the way, one of those planets, you might say, well, we're also going to put everybody on tirzepatide.
Mm-hmm.
And so you now have multiple different dietary treatments, when perfectly adhered to, that will dramatically improve obesity. One of those will be just a drug. Mm-hmm. Maybe two of them will be a drug. Another one will be a gastric bypass, et cetera. It still doesn't answer the question, what triggered the problem, right? It still doesn't answer the question. And again, I don't know that we want to spend too much more time on that, because these are unanswerable questions, but what is the right diet to fix it doesn't mean that the absence of that diet is what caused it.
Because even the point I was trying to make is that by saying to people, there is a right way to eat, we may foster a delusion. That is, The real debate perhaps is not between the low carb guy and the non-low carb guy as to what this thing is, or the eat locally, or, whatever. The real debate may be, is there a right way to eat, compositionally or behaviorally, or time of day or something, that will satisfy you, not make you feel deprived in the real world we live in, not in a parallel universe we could construct? And the answer may be no. And yet, by continuing to sell that idea, we may continue to have people searching in the wrong spot. Instead of searching for, how do I control or overcome my incomplete satisfaction with eating only this amount? And instead, they're looking for, what's the way to eat that I don't have that dissatisfaction? And I think what we may have to accept at some point is that for most of us, there are exceptions, but for most of us, to maintain a truly thin or lean body composition, if that's what we want, and I'm not saying everybody should want it, but for those who do want it, that we may have to accept that either we're going to have to alter our desires, in part through pharmaceuticals, or we're going to have to accept that we don't get to meet all our desires at times, as opposed to continue what may be the charade that there is a way that you can just eat a certain kind of food or certain type of diet, or eat in a certain way that will lead you not to ever feel dissatisfied. So I think that's an important sort of stoic approach, right? With a little more stoicism. Let's go back to something you were asking, though, about evidence earlier. And I do want to make a point about this, that we also need to increase the quality of the evidence and the standards we hold. We spend too much of our research budget on lousy evidence. So in the childhood obesity field, my group, for example, often will write letters to the editor. Another paper was retracted last week because we found statistical errors in it. And if you think about it, this was a randomized controlled trial of some treatment for obesity-related
behavioral.
I think so. And we find it in diet, behavior, et cetera. Not usually drugs. And what we see is, if you think about a randomized controlled trial, at the low end, a randomized controlled trial is usually over $100,000 to conduct. At the high end, it's tens of millions. The ones we're looking at that often we find these mistakes in, and many cases are retracted, especially in childhood obesity, are probably in the multiple hundreds of thousands of dollars, occasionally millions. And then you think, that's all wasted if they misanalyzed and misreported the data and got the wrong answer. So we kind of feel like we're rescuing those dollars in some sense by getting the wrong answers out and the right answers in. So we think it's an important service. But I think we need to hold our field's feet to the fire much more strongly on doing research that answers new questions, that answers questions well, that honestly reports the data, makes the data publicly available.
Do you think that problem, which I'm quite aware of course, is disproportionately present in this field, or do you feel that it's both acknowledged and demonstrated at the same frequency in all fields of medicine? Do you feel that this is we have a brighter spotlight on it here thanks to certain individuals? How do you think this stacks up?
All of the above, and so what we know is that there are many anecdotal statements by leading thinkers like Stuart Ritchie, as just one example, Gary Taubes, our mutual friend, who say nutrition is singularly bad. And some of these are wonderfully colorful statements. John Ioannidis said, we need to accept that nutrition epidemiology is a dead science and bury the corpse. That's a quotation, right? So those are opinions. Those are not bits of data. If we go further and we look at the Pew Charitable Trusts.
But hang on, one could agree with that on some pretty objective facts.
Sure.
But the question I'm asking is more on the challenges of experimental research that you're talking
Absolutely.
about, where real dollars are being thrown at experiments that are being done incorrectly or being analyzed incorrectly, or where the questions that are being asked are incremental, useless, uninteresting, and unlikely to add meaningfully to the fund of knowledge. Like, let's just forget about nutritional epidemiology. But I want to talk about this other, what seems to be more distressing problem, based on both the dollars that go into it, but also I think the confusion that it sows and the noise that it creates.
Right. So it's clearly created that confusion and noise, and that's what the Pew Charitable Trusts have shown, that in surveys, now we're talking data, in surveys of representative samples of American population, people trust nutrition experts, clinicians, purveyors of knowledge, more than they trust nutrition scientists. And they trust nutrition science less than they trust other forms of science. So that's a fact. We do have a trust problem in nutrition science. Now let's go to the last stage, which is our research really better or worse? Harder to pin that one down. There's not enough concrete, strong comparisons to other areas. We're trying to start some in our group. But there was a recent paper that came out in economics. Now it's not a one-to-one comparison, but in an economic journal looking at reproducibility. Reproducibility and replicability are not quite the same. Reproducibility is, can I get your original data, run exactly the same analysis you said you ran, and get exactly the same result? If I can, I've reproduced your research. Doesn't mean your result was right. Maybe you ran the wrong analysis, but at least I could do what you said you did. And we do that in nutrition and obesity, and we find we don't have exact numbers. It's not a random sample of papers, but we find what seems to be a not infrequent errors, irreproducibility, or what we call verification problem, meaning we could reproduce your result, but it was wrong. It was wrong because you ran the wrong analysis. We write the right analysis, get a different conclusion.
And you might do how many of these a year?
More than a dozen.
And of the dozen you run a year, how many turn out to be not reproducible or not verifiable?
I would say probably, again, these are all approximations, maybe half, but keep in mind, we're not randomly sampling.
Understood. What's the criteria upon which you select besides size of study?
It's usually one of two things. It's interestingness, or it's something doesn't look quite right. So if it's something doesn't look quite right,
your pretest probability is higher.
Then we take a closer look at it more often. Or if it's just very interesting, we say, that's really interesting, and it was published in Nature, and that could be, paradigm changing.
I'd be curious when you have enough data to know if you take out the that looks fishy sample and just said, hey, when we looked at the this is interesting, if half of those are coming up unverifiable, that's a crisis.
Yeah. And I would say we should do it. I hope there's a funder out there listening who will want to fund it. And NIH, as you might imagine, may not be always so keen on answering, having us answer this question, and it's hard to get that through. But yeah, we'd like to do that and hope we can do some more. We're doing little spot checks in the area. My sense is, even within obesity, if you look at pharmaceutically done randomized controlled trials, and I'm not trying to say that people at pharmaceutical companies or pharmaceutical companies somehow morally superior or not. They're people. They're just responding to their environment as well. But their environment is a very strong regulatory authority called FDA that holds their feet to the fire and so on.
Do you think that's the reason that drug studies tend to be very rarely found to require retraction?
In modern times, yes. In modern times, and if somebody said to me, do you trust randomized controlled trials coming out of the pharmaceutical industry more or less than academia? Infinitely more from the pharmaceutical industry.
Yeah, think about that for a moment. Let's just reflect. That's a big statement that I agree with you, but I think it's not intuitive to the average person listening to us. Many people listening to us would say, what? The data coming out of Pfizer are more trustworthy than the data coming out of Harvard? But the point here, the key point is that Pfizer has to answer to somebody, the FDA, who will, bring down a much greater and swifter punishment if issues are discovered in methodology statistical analysis, reporting, et cetera, whereas the academic community doesn't have that degree of policing, basically.
And the funding. So, often people say, oh, the industry is so much more efficient than academia because they have the profit motive. I think it depends what you put in your denominator of efficiency. If you say output per unit time, no question. Industry in general and pharma in particular blow academia away. But if you say output per unit dollar, academia probably blows industry away because we know how to stretch every penny.
Right. You guys are working on a shoestring budget.
Exactly. But that means often not much rigor. Whereas, the big pharma company who's going to put their registration trial in is checking and double checking and having professionals check and so on. Now, there may be more, I hate to use the word bias because it's not clear what that means.
By the way, it might be worth also explaining to folks that when people talk about quote unquote, a Pfizer study or a J&J study, they're hiring CROs to actually do the study. I think sometimes people are under the impression that, when Lilly is doing a study on a drug, it's like the whole Lilly team doing the experiment as opposed to Lilly providing the agent, helping think about the experiment, but basically having a clinical research organization actually do it and having independent folks do the analysis.
That's right. And I think that's important. Now, that doesn't mean that there's no, and again, I was about to use the word bias. I don't have a better word right now to use, but I use that one hesitantly. But there may be more bias in some ways in the industry-funded work. And that's often in the question asked.
I was just about to say, it's how the question is asked, which determines how the study is designed to look for a particular answer, for sure.
Exactly. So an industry group might say, I'll compare my new drug to the worst old drug in class.
Right. Whereas if a university guy did it, he or she might say, no, I'm going to compare it to the best drug out there.
But once they've decided on the question, then the design, execution, and reporting of the study seems to be enormously more rigorous in pharma. Now, that's not true if you said, what about dietary supplement industry? I'd say, okay, different game.
Show. Yeah.
More complex answer there. So back to this, I think we need better data. I think we need to assess this. I think within the non-industry funded stuff, typically, like the public health, the school-based stuff, the child obesity trials, it's going to vary a lot. So the cluster randomized community school-based childhood obesity trials tend to be quite poor. And I think the non-verifiability rate is very high. Whereas if you went to certain other kinds of trials, the NIH-funded clinical management of obesity trials will tend to be better. So it's going to vary a lot. And just hopefully I'm not biased, but I'm sure someone will think I am, and that's okay. They're entitled to their opinions on this. I'll disclose that I have funding from all these groups. So I've got most of my funding is government and NIH, but I have funding, and the school I lead is funding from industry, including many of the pharmaceutical companies, to think about clinical trials design and biostatistics. We're funding from food industry at times, commodity groups. So I just want to disclose all that.
So let's pivot now and kind of talk about the current state of obesity, which is really seeing a success it's never seen, and it's been a relatively short period of time. I think 3 years ago, very few people knew what semaglutide was, or even Ozempic, which is the trade name given to the diabetes version of that drug. Whereas today, I can't imagine too many people haven't heard the words Ozempic, or some of its derivatives, but I think Ozempic might be one of the most recognized of these drugs. So again, it's pretty remarkable. It's also worth noting that these are not new drugs, right? I mean, semaglutide and tirzepatide are newer drugs, but they've been around for a while. At least semaglutide has, and liraglutide and others have been around for a decade, at least a decade. And they've successfully treated people with type 2 diabetes. And like all things, or is often the case, you sort of notice something in treating one subset of patients that gives you an insight into treating another. And so basically, as people with type 2 diabetes were treated with this class of drug, you notice that it wasn't just improving their diabetes, they were also losing weight. And that led to what became a set of dedicated experiments to test the efficacy of these drugs in non-diabetic obese patients. And the rest is history. Talk a little bit about what you think is socially and psychologically happening at the moment. Why are people so interested in this drug?
Yeah, I think it's fascinating. I think people are interested for the obvious reason. And the obvious reason is lots of people want to lose weight, and lots of people want to help other people lose weight. And for the first time in history, as you've noted, we have drugs that are now powerfully effective and appear to be reasonably safe. We've had drugs that were powerfully effective before, but would kill you. And we've had drugs that were reasonably safe before, but at best, modestly efficacious. We now have ones that are powerfully effective and appear safe, reasonably safe. Safety is a social judgment, right? Not a factual determination. Risk is a factual determination. Safety is a social judgment. And so it invites all kinds of interesting speculations about cause. What is the role of GLP-1 in causing obesity? And is there a role? Just because things involving GLP-1 treat it doesn't mean it's involved in the cause. What's the effect on stigma? If we can treat it, does that reduce stigma in the same way that Viagra changed many things around erectile dysfunction? And interestingly, I sort of didn't predict the full cultural impact of that, which shows you it's hard to predict these things. People didn't predict what Viagra was for. It was being used for something else. They noticed erections as a side effect, and then they started working on it. And in the early 90s, when I went and visited one of my buddies who's a biostatistician at Pfizer, and that individual told me they were working on this new thing and explained what it was to me, I laughed at it and I said, what are you wasting your time on something so ridiculous and unimportant? Why don't you do some important research? Shows you what I know. So I think here we're learning that, again, that we get surprised in science. We're seeing a moral panic. This is subjective on my part, but this is something I'm noticing. A lot of old arguments that had kind of gone semi-dormant, at least in the academic community, over the years of, well, if you give people a drug for obesity, doesn't teach them anything. And therefore, when you stop the drug, the weight just comes back. And this was said as a criticism, as opposed to saying, well, who said it had to teach them anything? Who said that was the goal? And for many drugs, anti-seizure medications, if you have seizures, antihypertensives, anti-diabetes drugs, et cetera, you're going to take those for the rest of your life if you're in the right class for that. We don't say, but the person with schizophrenia shouldn't get the drug because if we stop giving it to them, the schizophrenia symptoms come back. Say, no, schizophrenia is a serious disease. We need to give it to them. With obesity, this has come up again. It sort of seemed to be put down that idea a few years back. And now I'm hearing it again, this kind of moralistic judgment about that. We're also hearing the moralistic judgments come about motivation. It's okay if you're motivated for health. It's not okay to get the drug if you're motivated for something other than health, which implies that assuming we have the same health issues, the person would equally benefit from their health. We make a moral judgment about your motivation, but there is no evidence that I know of that people who are motivated for health to lose weight do better than people who are motivated for cosmetic or any ego, business, any other reasons. So I think we need to get over some of that moral panic. Once we get past the safety, the cost, and the availability issues, and I don't want to trivialize those, the safety, the cost, and the availability issues are big issues. The safety issue is really, and in that sense, I'm defining safety in the sense that sometimes the FDA defines it, which is safety involves risk, and risk involves uncertainty, as opposed to being risk involving known factor, right? No, I don't just mean the probability that you get this. I mean the fact that we don't know what happens if you take it for 40 years. So there is some safety issue, some open questions. No one's taken it for 40 years, so we don't know what happens if you take it for 40 years. Right now, it's very expensive. Our country is divided on how healthcare should be paid for. There's a lot of different opinions. And also there's an availability problem. But let's just fast forward to a time when we say we've learned the safety.
And by the way, say a little bit more about the availability problem. I mean, I only realize it because you see compounding pharmacies now making semaglutide and tirzepatide, which when I first saw that, I couldn't understand how they were doing that legally, because that's pretty clearly not within the statute of what a compounding pharmacy can do. A compounding pharmacy can't make an existing FDA-approved drug. They have to make a variation of that drug. For example, they have to change the delivery mechanism if they make something topical that would only be available orally or something of that nature. Unless, and one of the exceptions to the rule is, if the FDA-approved drug can't be produced in sufficient quantities, then a compounding pharmacy can create the exact same drug that is available through the FDA label. So presumably that is happening. Do we have a sense of why it's happening? What is the manufacturing bottleneck? Obviously, demand is outstripping supply, but the question is, why is supply not able to meet demand? And then secondly, do you have any insight into whether the quality control at the compounding pharmacy level, it matches that of Lilly or Novo Nordisk?
So with respect to the first part, why is there an availability problem? I don't know the technical mechanics of it, but my understanding is that the technical process by which these drugs are produced is different than some other drugs. And the technical process is a slow one. And so until they ramp up more and more production sites, they just can't do it fast enough. But they are ramping up more and more production sites. So that's good. Novo just bought Catalan, which happens to have a plant in my backyard in Bloomington, Indiana. So we'll probably see more of that ramping up. The second thing is about the compounding pharmacies. So when I first heard about it, I'm far from an expert in compounding pharmacies or the legal aspects, but I too was skeptical. Is this okay? Was the quality control? And, is this a kind of shady thing? And I started to hear a lot of reports about this and described as though it was a very shady endeavor. And again, that moralizing came in again. Then I've talked to some other people who are experts in it and who are using these. And I've said, now admittedly, again, this is their business, so they have a motivation. But they have said, well, when we do it, and they've described, and I said, tell me your process. Who do you use? How do you do it? What quality control? And then they've gone through, say, for this compounding pharmacy that I use, we use it in this way, this degree of quality control. And I say, wow, that sounds to me, again, I have not physically inspected the plants. I'm not an expert in it. It sounds to me like some very rigorous quality control. So I don't think we should be dismissive of the concerns around compounding pharmacies, but I also don't think we want to paint everybody with the same brush. The question becomes, as with anything, is show me your data, show me your evidence on your quality control, your procedures. And if they're good, they're good. And let's use them. Let's get over the moral panic.
Yeah, I don't know that I think of that as a moral panic. I think the bigger moral panic is less about the source of the drug, but the use of the drug. And so you brought up an interesting distinction, which is let's take two people with obesity. Actually, let me take that back. Let's take an individual who is medically obese, and let's take an individual who is, and by the way, metabolically unhealthy, right? So that's the key point I want to get at here. So this is a person whose health is compromised by their weight, both from an orthopedic perspective and metabolically. And then let's take another individual who's overweight, but if you're looking at them objectively, you don't see the metabolic signs of overweight. They're not suffering physical and orthopedic issues associated with it. So both of these people, let's just assume, have a desire to lose weight. One of them to primarily ameliorate the medical conditions and also the aesthetic conditions, and then the latter person just for the aesthetic conversions, right? Okay. We probably look at those people differently. When I say we, I mean society might make a different moral judgment on those two.
That's right.
You're arguing that's a false dichotomy.
I think it's a legitimate dichotomy to see the situations as distinct situations, but not necessarily implying distinct recommendations coming from those. Let's refine it to a 2x2. We've got people, as let's just say 4 individuals come to you, and we're going to say that you're the objective, all-knowing agent. And
meaning I determine who goes on the drug?
No, you determine their state of being.
Got it.
Right? Half of the people are objectively at medical, physical risk because of obesity and would be objectively medically helped by losing weight on this drug. Half of the people are not at objectively medical increased risk and would not be predicted to have a major medical benefit. Within that, each of those groups, half of them think they have a medical problem, regardless of whether you objectively determine they do, and think they would benefit. And half of them aren't interested in that. They want to do it for cosmetics, income, other opportunities, etc., stigma reduction, quality of life. And the question is, how should those 4 groups be treated? Now, it seems to me, from an obvious point of view, if we're concerned about expense and the expense is borne by society, not the individual coming, or if there's shortages and we're going to take it away from someone who's genuinely medically needed, then going to the non-medically needy people is questionable. But if we get over those problems, if the person says, I can afford to pay for it myself, and the availability is there, and we think there's no big safety problem, or even if there's some safety problem, but we've told them, it's fully consented, take the libertarian view, it's their choice, it seems to me.
Yeah, and it's hard to imagine any reasonable person could argue with that position.
Well, one of the big statements that got in some news was a very reputable entity, major player in mainstream medicine, who has an interest in actually promoting this. And a 3 sort of step statement was made. Step 1 is the drugs were intended and designed and studied for this use, meaning treatment of medically needy people. Second, the drugs were approved for that use. Third, therefore they should only be used for that. And the third part is a moral judgment, not a factual
so really,
judgment.
the first and the second are true, and what they really tell you is, therefore, the cost-benefit analysis has to be viewed through the lens of that patient population. In other words, when you ask the question about risk and benefit, you have to at least acknowledge that the long-term risk, long-term benefit are studied in that population.
Correct.
And as such, this is what the data are. These are the risks. These are the benefits. Make your judgment. Conversely, if you ask the question, hey, for a person who is subjectively 10 pounds overweight, like me, right? Well, you could argue I'm 10 pounds overweight, right? Nobody knows but me, basically. But hey, should I be taking this drug?
So let's take an analogy. Patient comes to you. They're very wealthy. They're in good physical health. They have a house. They have a car. They have all the material things they need. They have a family. Family loves them. They don't engage in violence. And they say, I feel miserable. I'm anxious all the time, or I'm depressed all the time. You might say, you might try a few things, explore it, but assuming you've explored it, it's real. Maybe you tried some cognitive behavioral therapy, didn't seem to work. You might say, yeah, an anti-anxiety drug or an antidepressant might be for you. FDA approves those things. We take the person's quality of life and their feelings into account. Why is it that the person who says, I feel too fat and I want to be 10 pounds thinner and look good in my bathing suit, or I want to get this job as the leading actor in that film, or I want a promotion in my environment and I think I'm more likely to get it if I'm thinner, or I'm hungry all the time and I don't plan to lose weight. I just want to stop being hungry all the time. Why are that person's feelings or non-medical desires any less valid than the person with depression? Or for that matter, the person with an unusual but not health damaging physical feature, an unusual nose or something, who says, I just feel like I'd be judged better.
I don't think it is. I guess the only thing I would suggest as the backstop to that is when the person who doesn't like their nose goes to the ENT surgeon or the plastic surgeon to have the completely non-essential but emotionally beneficial procedure, if they're seeing a good surgeon, the surgeon can tell them with unambiguous clarity what the probability of negative outcomes is.
Right.
And I think the same is true in the case you described at the outset about the individual with depression or anxiety. A very good physician can explain to them what the risks are. And by the way, as you know well, very few physicians would give you a medication for anxiety or depression without also prescribing in parallel to it psychotherapy. The data are pretty clear that medication by itself is nowhere near as effective as medication coupled with psychotherapy. So you have two things going for you that make this analogy not apples to apples, which is in the case of depression, we can say much more about the long-term side effects, and we're combining it with a behavioral therapy that aims to improve the efficacy. Again, I'm not suggesting that the person who wants to lose 10 pounds doesn't have a legitimate concern. I think my concern is we don't know enough about the long-term risk to tell them for their relatively minor health compromise, is it potentially worth it? Is the trade-off worth it? I think we could probably say that with a higher degree of certainty for the individual with significant obesity, because even if we would have kind of a small bracket of understanding the downside potentially of the drug, we really know the downside of having a BMI of 40.
Right.
Right. Like, being insulin resistant, having type 2 diabetes, having a BMI of 40 has such a clear downside that, the other side of that bet is a pretty easy one to take. So I think that to me is so again, for me, it's not a moral question at all. When I'm confronted with this question, which I am all the time, right? Every week I probably, or every 2 weeks at least, interact with a patient who fits the exact description you're talking about, right? Which is, hey, I'd love for this to be easier. And again, I don't think there's anything wrong with wanting something to be easier. But my hope is we get to a point where we could give them the same degree of clarity around risk that the plastic surgeon can give the patient who wants to undergo a rhinoplasty.
Right. And I agree with you on that. And I think that's where you get into the moral questions come in around how do you conceive of the role of FDA, society, physicians in regulating choices.
And by the way, to be clear, that's why I'm not taking one of these drugs. Like, I'd love to be 10 pounds lighter. I would love to be 10 pounds lighter. I would love to never be hungry. Like, all of the things that these drugs do, by the way, they improve glycemic control. All of those things are appealing to me. But the truth of it is, for somebody who is quite a risk taker, and I am quite a risk taker, I've seen it. I am. When it comes to my health, I would argue I'm quite a risk taker. But I've watched countless patients take these drugs, and as I've shared with you and others, without exception, the resting heart rate overnight goes up about 10 beats per minute. And I don't know what it is about that fact and the fact that heart rate variability goes down slightly that just has me asking the question, for me personally, is it worth the trade-off?
Yeah.
Do I really? Is there some underlying sympathetic, parasympathetic imbalance that results from this drug that is doing a whole bunch of other good things vis-a-vis my appetite, potentially? But you know what? Over the arc of my life, is it worth it? And if it's, maybe if it were 40 pounds and it was medically a problem, I'd say, I'll take the heart rate bump any day of the week.
So informationally, I'm with you 100%. And in terms of the morality of the honest communication, I'm with you 100%. Well, by that I mean, informationally, we have a fair bit of data that allowed FDA to make its decisions on the use of these drugs for particular indications in patients who are judged to be, quote unquote, medically needy of those drugs. And we don't have a lot of data on the person who's thin, but who says, I just want it to be easier, or the person who's thin, but says, I'd like to be 10 pounds thinner. And I think any treatment or provision of something to people without a full disclosure of what you know and an honest disclosure is not right. So I think if I were in your shoes, I'm not a physician, I don't prescribe drugs, but if I were in your shoes and that person came to me, my bare minimum is that I've got to say to them, I want you to be aware that I have no data on this over many decades. We only have a few years. I want you to be aware that it was only tested thoroughly in these populations, which is not your population. And you need to know that there are, as Rumsfeld famously said, the unknown unknowns. Then I think there's an issue of choice. There are lots of things that I think it's acceptable that our society permits, but I don't personally want to do them. Think freedom of speech. I think it's perfectly acceptable and necessary that we allow certain people to come out publicly and make certain statements. But I'm not sure I want to make all those statements. And I can imagine you saying, I think it may be acceptable that somebody provides this drug to this person under these circumstances, but that's not what I want my career or life to be. And I think you should have that choice. So I think these are things we ought to do. And it comes down very much, I think, to this sense of after we have the inputs, we can agree on the facts, or we should be able to agree on the facts. But then what we do with those facts, that becomes, we can disagree because we have different values. And I think that's where it's how much of a paternalist is one. The FDA is very paternalistic, right? They're going to decide which drugs are good for whom. Or how much are you a libertarian, where you say, we'll tell you about the effects to the extent we can of this drug or this treatment, but how good it is, whether you should do it, whether you want to do it, implies values. And you make that decision as long as it's a fully informed decision. And those are different views of how we should proceed.
All right, let's consider one more zinger on this topic. You are now in charge of both WADA and USADA.
Okay.
Right, so World Anti-Doping and U.S. Anti-Doping
thank you for
agencies.
Defining those for me.
You have an obvious and clear hard line against drugs that improve performance. So an athlete cannot take testosterone or growth hormone or EPO or anything that boosts performance. Now, if you think about it, a lot of sports have their performance improved when the athlete is lighter. Weight management is a big part of many sports. Cyclists, runners, gymnasts. If you think about it, rowers, any sport that is cardiac output versus body weight, those athletes, and I used to be one of them, you are just as focused on weight management as you are cardiac output. Should these drugs be banned by WADA and USADA? Are they indeed performance-enhancing drugs?
Great question. I hadn't thought about that until you asked it. Great question, because it introduces a whole different set of interests. Prior, we were talking mainly about the individual person's taking the drug's interest and a little bit about the provider's interest, a little bit about society, cost, FDA, so on. Here you've introduced a fourth party, and that party is the sport. All the spectators, the people who own it, the other participants. The sport has rules, and sport is very different than some other things where there's an arbitrariness to it, right? Why does the baseball bat have to be this long and not that long? Why does the tennis racket have to be within these dimensions?
Well, that part's arbitrary, but what's not arbitrary is we want it to be equal. We want everybody to have the same chance. So in other words, we don't spend too much time worrying about the length or weight of the baseball bat. We worry far more that you didn't screw into yours and put cork in there and change the weight of it. That's the thing we care about, is fairness.
Because that's the rule. But the rule, we even changed the rules about the intrinsic things. So we changed the rules about, in some places, we don't condition on age. In others, we have age brackets. Some boxing, we have weight brackets. Wrestling, we have weight brackets. We don't have height brackets in basketball. And it's interesting, some colleagues and I are trying to write a whole paper on, mathematically, what is bias? What do we mean by that? And we use basketball as an analogy, and I use myself as the example and say, if I try out and I don't do well for the basketball team because I'm short, I don't call that bias, because intrinsic to the idea of basketball is these are the rules. We don't have springboards for shorter guys. We could, but we don't. We don't have height classes. And so that's not biased. In contrast, if you ask me to try out to be a biostatistics professor and the book is on the top shelf that you want me to lecture from and there's no step stool, I would argue that's biased, because you could have put a step stool there and it's not intrinsic to biostatistics professor performance to be able to reach tall things. And so we need to look at the sport and say, what do you want it to be? And if somebody says, I want it to be things where part of the sport is being able to maintain your weight, and so I don't want anybody to have a performance-enhancing drug, then to me, so be it. I could also alternatively turn around and say, we just want you to be able to get the basket in the hoop, or we just want you to be able to row the boat. And if you do it by having more money and hiring a better coach, and you do it by taking Ozempic, and you do it by having good genes, all is fair. And I don't think there's a right answer there from the sport point of view. I think you just decide what is.
But given that the sport has already made several decisions, right? They've already said you can't take a drug that increases the number of red blood cells that you have. Mm-hmm. That's EPO. You can't take a drug that increases the rate at which your muscles repair themselves after hard training. That would be testosterone, right? You can't, and go on and on and on. You can't take a drug like a diuretic that takes body weight away from you. I just wonder where, this is not a philosophical question about drugs. It's a practical question about this class of drugs whose efficacy is, as you said, profound, and its safety, at least in the short term, unquestionable. Are we going to basically see at the Olympics this year in France, if they were drug testing for it, what fraction of athletes would be taking GLP-1 agonists of the sports where body weight regulation is a key? I don't expect many shot putters to be taking it, but I do wonder how many boxers and rowers and runners and cyclists will be taking it.
Really interesting. We should do that study. Let's work on it. So I don't know the answer. Haven't heard about that before. I think your speculation is apt. I think that as a formalist, I would go and say, well, what is these groups that have said you can't take testosterone and this and this and that? They probably put out some underlying principles. They probably said you cannot take a drug that enhances performance unless you have a medical need. I don't know if they've said that, but if they have, then it could get really tricky because now you say, well, who defines the medical need?
That's right.
What about, now is it fair if we take the person who's just below the threshold for needing it, who says, I don't get to take the drug, but the person who's just above the threshold who does? You have then also this idea of a fairness, a disabilities issue. If I have obesity and I've got a strong genetic predisposition to it, and I can't manage to be not obese without the drug, do I effectively have a disability? And is this now prejudicial or violation of, the Americans with Disabilities Act or something like that? Or, different countries have different variants, but is there a fairness issue? And again, I don't know that there's a right answer. I think these would be tough political and moral questions, but it's really particularly tough because you bring in the interest of the sport. And then you're going to get also, it's going to reflect back when you get into the health interests of the individual, just as with many sports, we might say it's in the interest of the team or the coach or the sport itself to have this person at greater risk. But of course, it's not in the interest of their situation. And yet we somehow accept that we allow people to play football, even though there's concussion risk, and we allow people to box and many other things. But are there some limits where we might say, we're not comfortable with your putting yourself at risk for this. We need to protect you as much as the sport.
All right, let's pivot to something a little bit easier to talk about. You've already alluded to protein. It's a huge interest of yours clinically, personally. It's a topic I've addressed a number of times. What do we know about protein, and what do we, at least in your view, what do you think we know that we don't know?
Okay, so you're as much or more of an expert on the physiology and biochemistry of it than as I, but I will venture a few things. So with respect to what we know some very basic things. We know you can't live without protein, without consuming some protein. We know that the body is made, not totally, but heavily, of proteins. They're essential for functioning. We know that proteins are made up of amino acids. They're different amino acids that have different effects. Some amino acids can be synthesized in the body, some can't be. I think you did a podcast with Luc Van Loon recently, which I found enormously educational. And so I'd refer people to that one. And he knows a lot more about protein than I do. And so I think we know that we need protein. We need a certain amount. We need certain amino acids, and we can get them from various foods or combinations. Animal-based foods, we can pretty much get all the proteins we need from them. If we only eat plant-based foods, it's not impossible, with the exception of maybe taurine, but whether we have to consume taurine or not. If you're a cat, you have to consume taurine. But if you're a human, maybe not.
You could drink Red Bull and
go.
Still eat plant-based protein, and you're fine.
So then we get into, are there known things about the amino acids in terms of long-term human health? And I think modest. So, we see certain things about leucine being important for skeletal muscle growth, anabolic effects. We see some things about isoleucine in mice maybe not producing longevity. We see taurine supplementation in mice and some other species appearing to prolong life in Vijay Yadev's work. We see methionine restriction in Rich Miller's work prolonging life. Thionine's related to taurine. So a lot of confusion. What will really prolong life in humans is unclear. Whether the same things that will prolong or shorten life in terms of macronutrient composition in mice will do the same thing in humans is unclear. And there are different outcomes. This is, again, part of why I railed against the idea of healthy foods, so-called, or unhealthy foods, so-called. Healthy for what? You might want to be 10 pounds thinner. I might want to be able to lift 10 more pounds on the bench press. That person wants to live 10 years longer. The three diets for those things may be different. And so I think that after the idea that we need some protein, we need some minimal amount, we need the amino acids, I think it gets shaky then. Some of the things that are said are,
in other words, minimums and maximums were not necessarily a part of what you just described with much certainty.
Right. I think there's reasonable confidence, and you've been a great progenitor of this idea, that the old school recommendations for this much is enough were probably too low.
0.8 grams per kilogram body weight is the RDA.
Right. And I think many people think that's too low, that you can survive on. It's not that you can't survive, but can you thrive? And that's sort of, I think, a big point of your book and other people's lives, your book Outlive, which is, yes, we can think about treating diseases, we can think about preventing diseases, but neither of those are equivalent to optimizing our lives and our health. And, different people have different ideas of optimal. Is optimal comfort? Is it optimal length? Is it optimal ability?
Performance? Yeah.
Whatever it is, it doesn't seem that that's the level, the LRDA,
Right.
0.8 grams per kilogram, is the optimal level for health or longevity or anything else. So it's probably somewhat higher. Next question is, are there minimal thresholds at any sitting? So Don Layman and others have argued there are. Sometimes you hear 20 said, 20 grams. Sometimes you hear 30 said. So 20 to 30 grams in a particular sitting is the minimum to get anabolic. Is that true? When I, as a statistician, hear this, I'm like, really? A threshold in biology? You're telling me there's a step function and you know it? Now, I don't really believe it's a step function, but maybe it's sigmoidal. Maybe it's sort of a little flat and then it goes up steeply and then it flattens out a little bit. And then I say, how much sample size and how many different doses would you need to really get a fix on that and test whether it's there? And then you look at the studies done and you go, you've got to be kidding me. We talked earlier about pharmaceutical company studies. Think about the numbers of people on which we tested COVID-19 vaccines. Think about the numbers of people we've tested statins and now GLP-1 agonists. Now think about the numbers of people used in randomized controlled trials from the nutrition community to look at protein needs. And not all of us need to take a statin. A lot of us do. Not all of us need to take GLP-1 agonists. We've talked about that. All of us need to eat protein. And yet the quality of evidence and the quantity of evidence we have is tiny. It's dust compared to what we have on these pharmaceuticals. And so we really need to ramp this up. I would say, I don't think that we really know that you don't get anabolic until you hit 20 or 30.
But again, just to be clear, I mean, the mechanisms that are described on those are based on small studies. And they're really small by necessity, just based on funding and complexity of doing these studies. Right. I mean, these are amino acid labeled tracer studies, right? Where they give people various doses of protein and they look at muscle protein synthesis, right? And so, again, I'm not here to say that we shouldn't be doing bigger, better studies, but, some of the studies that have been aimed at elucidating this are quite rigorous in terms of their mechanistic insights. And so I guess the question is, isn't it at least biologically plausible that there is a threshold? And I agree, it's very unlikely a step function. It's more likely a sigmoidal shaped curve. But it seems at least biologically plausible, which doesn't make it right, that at low doses, at 10 grams of amino acids, the liver itself might just prioritize gluconeogenesis. And there's a saturation point at which it says, oh, well, okay, we have excess nitrogen now. Let's go off and do this other thing.
I think it's entirely plausible, but we talked many times.
Yeah, lots of plausible things turn out to be wrong.
Exactly. So we need to do the studies. I'm not putting anybody down for these studies.
I get it, yeah.
Some of them, when I hear about what Don Layman's done and what Luc Van Loon has done and others, it is really impressive and rigorous. But as a statistician who's saying, do we know the answer?
Yeah.
I say, not really. And we're also interested in long-term effects. And so there's, that old saying, there's many a slip twixt cup and lip.
What's the saying?
There is many a slip twixt between cup and lip. Right? So you drink and you spill. You think it's a done deal. If I've got the cup and I'm moving it toward my mouth, I get the drink, but maybe not. The tracer studies are important, but they're not.
They're indirect.
Right. What we really want to know is, if you do this for a year, are you stronger? Are you bigger? Are you, et cetera? Yeah. So I think we don't really know that unequivocally. You did a great discussion recently of a study that was in which Luc Van Loon was one of the authors, that used up to 100 grams and looked at the other end of the threshold. Yep. Is there an asymptote? Is there a level in which you don't get any more benefit?
Right, where conventional wisdom was 40 grams-ish was the ceiling. And I think the study from Luc suggested, that might be true for a very rapidly hydrolyzed protein such as whey, but with casein, at least his data suggested maybe not.
That's
Time-release protein might be a value, and meals, like a steak, might be closer to casein kinetics than whey kinetics.
Right. So I think we don't know that there's an upper limit. We don't know the full duration. Some people said you only stay anabolic for 2 hours after eating the protein. I think that Luke's study shows more.
Yeah.
So I think there are those things.
What about the maximum amount of protein? Again, traditional thinking here
Great
is
question.
3 grams per kilogram is the maximum. And if you consume more than 3 grams per kilogram, as a healthy individual, you risk kidney damage.
Right. So this is something that's been intriguing to me. When I look at this, and I haven't done a complete thorough check, but I'm sort of in the process of working through it, I hear it's going to reduce bone mass, or could reduce bone mass, excessive protein intake, that is, could lead to kidney function problems, some other unspecified problems. There's even this old thing called rabbit starvation, which, you can find papers going back on this at least 100 years. And they talk about hunters and survivalists and so on out in the woods who can shoot a lot of rabbits and eat their fill of rabbits and yet starve to death because they don't have enough fat and carbohydrate to properly digest. But if you say, now, let's go back and find the trials that showed this. So you find a paper and it says, here are the limits. Steve Heimsfield and Sue Shapsis just had a wonderful Nutrition 101 commentary in New England Journal of Medicine. And they talk about some of the upper limits, and they cite some papers, and they say some bad things can happen if you eat too much protein. You go back to those papers. They're review papers. They're not trials. Those papers say the limits are like this, and they cite a few things. And you keep going back, and we're unable to find trials where people do it. All you seem to get to is somebody said, well, but there was this group of hunters in this population who ate this many grams, and they were okay. So don't go above that. But nobody said, if you go above that, something bad happens. There's this study, and I say loosely, of 1 or 2 guys who ate nothing but meat for 6 months to a year, and they were fine. Interestingly, there's a corresponding study from 1928. 2 Polish scientists put 2 Polish people on a diet for 6 months of nothing but potatoes, fruit, and a little bit of fat to cook the potatoes in. And the idea was, can you get enough protein and nitrogen out of the potatoes? And the answer was yes, at least for 6 months, they were fine. So people have been fine eating nothing but meat and no plants for 6-12 months. Again, these are semi-anecdotes. They're intervention studies, but they're not big randomized controlled trials. Or nothing but potatoes for 6 months as a protein source, and they've all been fine.
Do you remember in any of those studies how much weight was lost in each group?
In the potato study, there was neither weight lost nor gained.
Really?
Yeah.
How did those people not lose weight?
They were probably thin to begin with. If you go back to the classic studies of Ted Van Italy and Sammy Hashim from 60s, I think, where they would bring in, as they described them at the time, lean Columbia University students versus obese adults. And they gave them Metrical, which was sort of the Boost or Ensure of 1960, and through a tube where they could get unlimited supply, but they couldn't really see how much they were eating. And what they found is that the obese people generally lost weight. They didn't fully compensate, or the monotony made them reduce intake, whereas the lean students all maintained weight. So it's probably that the effects of diet on weight change vary a great deal depending on where you're starting. Anyway, so the potato eaters neither gained nor lost weight, and they had beautiful nitrogen balance. From what I've understood, I haven't studied those papers as carefully, but all meat eaters, at least for 6-12 months, were fine. So I think either way it can be done. What I have not seen is somebody who said, to test this rabbit starvation thing, we brought a bunch of healthy adults in and we fed them nothing but cooked rabbit for 6 months, and something good or bad didn't happen. I've not seen somebody say, we fed enormous levels of protein to normal adults and we saw leaching of bone mass.
And by the way, do you think that study would need to be rabbit because it's so lean, or could it be ribeye, which is equally void in carbohydrate, but at least is high in fat? So from a macro perspective, you're dividing things up.
I think it depends on what you think the mechanism of action is, and it's not crystal clear to me that people have specified a crystal clear mechanism of action. There is some speculation, and again, there's some nice recent papers on this, that especially for people who want anabolic effects, bodybuilders, weightlifters, that when you eat when you eat protein, you should have some carbohydrate with it that will enhance the anabolism because
through the insulin.
Exactly.
Or you inject insulin.
But my understanding, and again, I'm just really entering in this, but as I've read so far, there is no compelling evidence that that is true. That is, that you get more anabolic effect if you eat carbohydrate with your protein than if you eat protein alone. So another presumption or myth. So rabbit starvation, bone loss, kidney problems, and you must have carbohydrate with it. All of these things are, I think, these things that are presumed known and readily talked about, but I don't think demonstrated. So I've not seen any trial data yet in normal adolescents or adults that suggests a negative health problem, not conjectured, but observed as a result of too much protein. Now, I'm not saying there isn't such a study, but I have not yet found those studies. If anybody else knows them, please send them to me.
Yeah, that would be interesting. And let's just assume that those studies don't exist, in fact, or if they do, they're very, very small and therefore probably not worth extrapolating to the ends of the universe on. What is the probability that such basic questions like this will be answered in the coming decade of nutrition science? What is the appetite, no pun intended, for this type of clinical investigation, especially in light of everything else we've spoken about, which is, hey, the name of the game in nutrition science now is pharmacology. It's not these sort of mundane questions about macronutrients.
For obesity treatment and closely related things, diabetes treatment, prevention, I think you're right, the name of the game. For other areas, I think there'll be more interest. So longevity promotion, and you'll get something like the Evolution Foundation weighing in, which could conceivably do big studies. But even there, I mean, nothing's unlimited. They may say, well, we're going to focus a big trial that'll be definitive and really give the answer, but it's going to give the answer only in this age group or something like that. I think NIH will fund some. I think industry will fund some. But NIH industry are likely to fund, in most cases, things that are small enough that we're not going to know the answer about every dose eaten at every period of time in every race, age, sex, and health status group. What we'll know is pocket answers. So I think what we could get, for example, is a study funded in which we very, very thoroughly looked at ordinary healthy adults over 60 years old who want to increase strength and muscle mass, and we'll look at protein intake and we'll look at other upper limits. I think that could conceivably be done, and we could probably nail that answer. But then you might come back and say, well, you've shown it's safe or unsafe for a 60-year-old. You haven't. That doesn't mean it is for a 20-year-old. And we're saying, that's true. And you say, well, you showed it with casein whey, but not with pea protein and, whatever. That's true too.
So how compelling do you find the data that high protein diets reduce longevity? There are many proponents of this view out there. Often, I suppose, within the plant-based community, although again, I don't think those are necessarily an overlap, although that just seems to be where I notice most of the lower protein is better rhetoric. But how do you assess the strength of that claim?
Very low. I think it's going to depend on species, and that's important because it leads to the extrapolation issue. If you're a butterfly, I think it probably does reduce lifespan, and I think a higher carbohydrate diet may increase lifespan more if you're a butterfly. If you're a mouse.
And, we do have some butterfly listeners of this podcast, but I'll be honest with you, our efforts to increase butterfly listenership have largely been, I would just say they've been less successful than I would have enjoyed.
We'll keep working on that. But I think in humans, there's no compelling, in my view, no compelling evidence. I would even say there's some evidence and reasons to believe the contrary. Some of that's going to be tied to wealth. Wealthier people eat more protein than less wealthy people, including within our country. So it's hard to tease all this apart in epidemiology. But if you look at the association studies, even there, I don't find it compelling. Then you can say, well, do you accept the association studies? And say, not all that much. If you look at the mouse studies, I'm not sure there you see the full translation. But also, I'm not sure they're all that compelling, that low protein. So I think nothing that I know of would say to me there's very strong reason to believe, even if not definitive RCT, that higher protein will lead to less longevity. And if anything, I think there's more compelling reason the contrary. Now, my friend and an IU alumnus, Barry Sears, talks about the zone diet. And the idea of the zone is that there's not too much on this end. You shouldn't be too high on this end. Don't be too low over here. There's a zone of things in the body and in diet that are right. You got to find the right spot. And he very strongly believes that you want to upregulate AMPK to live longer, and you want to not upregulate mTOR too much to live longer. And I know you've talked about rapamycin, which sort of has effects that would go along with what he's saying. So he might argue, from that point of view, that too much protein would reduce longevity. And again, I can't say he's wrong. I think it may also depend on at which period of time. So what's good for you to do or eat early in life to prolong life, may not be what's good for you later in life. Sometimes we call that antagonistic pleiotropy. And here we might say, and John Hollisey found this in rats. Now, I don't know if it holds up as one study, but found that exercise in rats reduced mortality rate in the first half of life, but it increased mortality rate in the second half of life. And so if we accept that as causal and valid and replicable, then maybe the same things might be true for protein. It might be good to eat more when you're younger and less when you're older, or less when you're younger and more when you're older. I don't know. But I think that we also need to think that longevity is only one factor. We talked about this a little bit the other day, and there's no right answer to this. But if somebody were to say to me, live this way, and our best guess is you'll die 2 years earlier. But until you die, you'll be stronger, you'll feel more energized, you'll look better. I'd say, I'll make that trade. Now, someone else might say, I won't make that trade. And who's to say who's right?
David, one last thing before we go. You serve as sort of the editor of a newsletter that comes out every Friday, Obesity and Energetics. I've been a subscriber for, I guess, a decade, maybe a bit more, right? When did it start?
It started kind of organically all the way back when I was just in grad school, basically, getting out. And then there was no formal letter. I didn't have the internet. I would hand my professors papers I had read and said, hey, maybe we could talk about this or something. Then I moved away. I would mail them, and then I'd mail to a couple of people. And it kept going. And soon people started asking to be adding to my list. Then it became electronic. Then it became a formal web thing. So now it goes out to over 100,000 people worldwide. We don't charge anything for it. It's free. It's called Obesity and Energetics Offerings. We don't accept any commercial support for it. It contains usually about 100 or a few more links to mostly scientific papers, sometimes popular media articles commenting on things in virtually every category related to obesity, energy metabolism, nutrition.
Well, I'm a big proponent of it. My team all subscribes to it, and it's one of the it's one of the not too many newsletters that I rely on. Again, people ask me, how do I stay up to date on things? And the truth of it is I have to rely on other people doing a lot of the aggregation, and then I'll kind of go where my curiosity goes and sometimes go a bit deeper. But anyway, I just wanted to make a plug for people to subscribe to Obesity and Energetics Offerings. It's great. And you know, one of the fun things that I think is great for people learning is one of the sections is always called headline versus study.
Yes.
And I just think that's, if folks listening to us now are not going to read any of the subheadings there, just read that one, because it gives you a great sense of how misleading the traditional media can be. Not necessarily because they're nefarious. I don't think that's the case. I think it's scientific ignorance and a misalignment of incentives. So one, they're simply not qualified. They don't have the scientific literacy to understand what a study shows. And secondly, they're really incentivized to get you to read a study and click through something. And they have to come up with a headline that makes that appealing. And as you point out every week, there's a great example of one where the headline is patently false at worst, and at best so misleading as to be useless. So what I think is valuable for folks is to get into the habit of checking that once a week and seeing, hey, that was a headline. I could see that headline. I could see how I'd get I'd get duped for that. But oh, there's the study. That really had, the headline could be something as outrageous as women are so much more likely to, outlive their partners if they have sex 3 times a week. And then you look at the study and it's about this rare species of fruit fly that sometimes mate with male fruit flies that die a little premature. Like,
Exactly.
I mean, it can be so ridiculous.
Well, I really appreciate your pointing that out. And anybody can subscribe for free. Just type into Google Obesity and Energetics Offerings. You'll find it. If not, email me. And I hope Andrew Brown, who's a professor and a former mentoree of mine at University of Arkansas now, is listening. He took over handling that category a few years ago. He does a beautiful job with it. And so he sets these things up and often finds these interesting things, and even got to the point where others picked up on his use of the phrase in mice as kind of like a standard thing, which is just as often a way of saying, well, we found this in mice. But the in mice is often left off in the headline. So
how many people are involved in curating that list each week?
It's in any one week, it's about 5 people, including me. So there's me, there's an editor, then there's Andrew who cleans everything up, and then there's Colby Vorland who cleans everything up, and someone else who posts it.
That's a lot of work for 5 people.
Of work. But it rotates. So the editor rotates every week, but the rest of us, including me, are on.
Thank you for never asking me to be an editor on that.
I hadn't thought about it until now. Maybe I will.
No.
It is a lot of work, but it's fun. It's a labor of love.
Yeah. Well, David, thank you so much. This was a super fun discussion, and I know that folks are going to get a kick out of it.
Thank you, Peter. Great to be here with you.